Imagine two people trying to speak at exactly the same time during a phone call. Neither message is clearly understood. Something similar used to happen in computer networks. Welcome to the packet journey. In this video, we're going to understand what a collision domain is and why it played an important role in Ethernet networks. Let's get started. In older Ethernet environments, devices often shared the same communication medium. Only one device could successfully transmit data at a time. If two devices attempted to send data simultaneously, a collision occurred. A collision domain refers to the part of a network where packet collisions can happen. All devices sharing that segment belong to the same collision domain. In the early days of networking, hubs were commonly used. Because hubs simply repeated incoming traffic to every connected device, collisions were much more likely. As more devices shared the same hub, the chances of collisions increased. Modern networks typically use switches instead of hubs. Switches create separate collision domains for each connected port. This significantly improves performance because devices can communicate more efficiently. Let's imagine a switch with four connected devices. Each switch port represents its own collision domain. If one device transmits data, it doesn't interfere with devices communicating through other ports. You can think of a collision domain like a single lane bridge. If two cars attempt to cross from opposite directions at the same time, problems occur. Adding multiple bridges allows traffic to move more efficiently. Today, collisions are far less common because of switching technologies and full duplex communication. However, understanding collision domains helps explain how Ethernet networks evolved over time. So, in summary, a collision domain defines the area where packet collisions can occur. Switches reduce collisions by creating separate collision domains for connected devices. Understanding this concept provides valuable insight into how modern networks achieve efficient communication. In the next video, we'll explore Zero Trust Network Access or ZTNA and understand why organizations are rethinking traditional remote access models. If you found this explanation useful, please like the video and consider subscribing to the Packet Journey. Thanks for watching, and I'll see you in the next Packet Journey.